Good morning. Thanks for joining us today. My name is James Ling. I'm working for Greenovate Europe, a sustainable innovation network based here in Brussels. I'm with dissemination partner in the HOOP project, who's hosting today's webinar. So the HOOP project is a Horizon 2020 project. Probably you've already heard about it. We're boosting innovation in circular bioeconomy in cities and regions. We're in the final year of our project now. Finishing up in September. So we're currently launching today a webinar series to present to you some of the results, some of the lessons learned during our project. So today is the first of 4 webinars that you can enjoy in the next month. 2 more in a couple of weeks, another one at the end of the month. Here you have the titles on the screen. So we hope you'll join us for a few more of those webinars to hear from our experts and from our cities and regions about some of the learnings from the project. So just to explain a bit about today's webinar, we're recording the webinar, so no stress about that. It's going to be shared afterwards. The slides are also going to be shared, so you'll be able to catch up with everything afterwards. As attendees, you're in listen-only mode, but we're really hoping you'll share lots of questions with our speakers via the Q&A function. So we've allowed time for that, so please don't be shy with your questions. And with that, I just want to really introduce the speakers. Today we have 2 expert speakers with us from the HOOP project. Elisa Gambuzzi from CETENMA, the coordinator of the project, and Christoph Baumann from AWM Münster. So I'm not going to take any more time. We have a short webinar this morning, so I'll give the floor straight away to Elisa for the first presentation.
Hello, James. Hello, everyone. Thank you very much for introducing me. So let me share my presentation with all of you. It will take about 20 minutes. If you have any questions, as James said, please write them in the Q&A section. If I'm good enough to manage time and we have some leftover minutes, I will be happy to answer right after my presentation. Otherwise, in the scheduled Q&A session. Okay. I hope that you can probably see my presentation. Do you see it full screen?
Not right now.
Okay, I was thinking it would happen. Now?
Yes.
Okay, that's great. Thank you very much. Okay, so this first presentation is the first one of the second series of the HOOP webinar series. So it's a kind of introduction to the basics of our final aim, that it's the valorization of biowaste. So what is the basic? The basic is performing a correct selective collection of biowaste and have an idea of what are the technologies available for the valorization of biowaste streams. And I also provide you some insight from our different lighthouses. But of course, then Christoph Baumann from the Lighthouse of Münster will dive much deeper into their cases. As James said, we are the coordinator of the HOOP project. So who we are a relatively small technology center located in the southeast of Spain, and we have like kind of different areas of study related to energy efficiency and circular economy. And we have 4 labs that we can use to help our theoretical research on indicators and methodologies with these practical tests on lab and demo scale. So we have the laboratory of water, NGs and calibration, biorefinery and bioenergy, and energy efficiency. And now, in just one slide, what's HOOP? HOOP is a very complex project, but if we have to say it in a few words, it's a project that provides PDA, project development assistance, to cities and regions across Europe, with a large focus on our 8 demonstrators that we call the lighthouses, and of course with a replication strategy that aims to deliver all the knowledge and the tools to the HOOP network of cities and regions. HOOP was born from 3 parents that are the mother project, Waste Up, Biowaste, and Excalibur, that have ended. And from this mother project that were more on the upscale of technologies to valorize biowaste, we built this PDA HOOP project. So we provided our lighthouses with the biowaste valorization routes available from the mother project, plus others that we found in the state of the art. We provided them project development assistance under the branches of legal PDA, business PDA, technical, technological, environmental PDA, etc. And of course, stakeholder engagement was a key part of the success of the lighthouses in implementing the urban circular bioeconomy projects. So now let's go to the first pillar of this presentation. The different strategies to collect biowaste and different results that you can get. First of all, just to be sure that we are all understanding what we mean for biowaste. Biowaste from the urban environment can be kitchen waste, garden waste, specific waste streams from the HoReCa sector or some industrial sectors like coffee, meat and fish byproducts, used cooking oil, and of course wastewater and wastewater sludges. But when we think of biowaste, we must always take into account that within the municipal territory, there can be agri-food industries and also some agricultural farming exploitation. So also these 2 sectors can generate biowaste. That is, it's actually much more easier to valorize because it's homogeneous and there are like much more technologies that can apply to this kind of biowaste. Okay, as you may have started to understood from the previous slides, the quality of the biowaste is a key factor when it comes to considering how to valorize the biowaste stream. In this slide, you can see an evolution of biowaste collection system from some decades ago to what you can see nowadays. At the beginning, we were all collecting biowaste in a non-separate way, so everything went to the gray or black, depending on where you live, bin, and then all this rubbish was sent to the waste treatment plant, where through the mechanical biological treatment, we could separate kind of very dirty biowaste to other waste types like cans or plastic, paper, etc. This was not really effective in terms of valorization perspective, because you can do almost nothing with that biowaste that you have separated from the pool, because it's so dirty that you can't use it for anything. You may stabilize it and then leave it on the landfilling, but definitely you can't do anything with that. And then it came the separate biowaste that, by the way, is now compulsory from the beginning of this year across all Europe. And there are different systems that you can use. You can use systems with no user identification, like bins on the street, where everybody can go there and drop their organic waste back, okay? And you have to basically rely on the fact that people including that bag uniquely biowaste. And then there are systems that allow a user identification, like the door-to-door collection or the collection on the street with kind of chips or cards that allow the identification. And these really allow to achieve a much better quality. Once you have planned which system you want to implement in your city to collect biowaste, you have to understand that the quality of the biowaste must be kept and possibly improved. And how do you do it? There are basically 2 aspects that you must consider. First of all, you have to inform the citizens about what kind of waste they have to put in the brown rubbish bin, the bio-waste rubbish bin. And then, of course, you have to control, you have to perform controls and some correction actions if it proceeds. This is quite an expensive system because, for example, this is an indicator that I found in literature. If you want to perform an effective communication campaign to the citizens, I mean, sustains along the year with contents, etc., it costs about €5 per citizen. So, I mean, you can easily understand what is the cost for a big city. But it definitely worth the effort, because you can see in this graph that I prepared for you what is the quality of the bio waste. And when I say quality, I say the absence of undesired material versus the cost of the collection system. Of course, on the cheaper side, we have the non-selective collection that allow us then to separate a kind of bio waste stream that is absolutely useless. And then we have the bio-waste bin on the street with no user identification. According to the pilot experience in Murcia, you can get a quality of 50%. It means that half of that is literally non-bio-waste. So yes, let's say the cheapest system to selectively collect bio-waste, but then you must either have a very strong pre-treatment system on the waste treatment plant, so that you must be able to very effectively separate that half fraction that is not bio-waste, or either accept that you cannot do that much with that bio-waste. And then we move to the door-to-door collection that really allows to have a better quality. But if you want to keep decent qualities to obtain compost and other soil improvers or other high added value bio-waste derived byproducts, you must seriously take into account that you need periodic communication campaign together with a door-to-door collection or any collection system that allows to identify the user, or door-to-door collection plus communication campaign plus incentives. And when I say incentive, I also mean fines if it makes sense in your specific environment. Here I leave you, just for inspiration, some example of excellence within the HOOP consortium when it comes to bio-waste collection. And as for AWM, later you will listen to Dr. Christoph Baumann to give you some more insights on how to get to these wonderful results. And then let's switch to the valorization. Again, I want to give you some examples from the lighthouses, and I don't want to dive deeper into the many technologies because it would be like 2 hours or 3 hours speech from my side, and it really doesn't make no sense. Okay, so this is Lipor. Lipor is the waste management company of our lighthouse Porto. They implement separate collection mainly door to door, and I say mainly because there are some neighborhoods that may have a different system. The quality that they get is quite good, but still they need a very effective pre-treatment of bio-waste when the stream enters the treatment plant, because they need to remove the unwanted material. After that pre-treatment unit, they get such a good quality bio-waste stream that with that very good bio-waste stream, they produce, for the moment, only compost, different kind of compost, but they are really trying to widen their offer because the local market is asking for more soil improver, maybe including other kind of recovered nutrient. Their success story is the compost Nutri-Mais, that as you can see, it comes in very different version. It has a super high quality, and it has a very market demand and quite a high market value. And it's used especially from the winery from the winery industry. Porto wine is famous everywhere in the world, and yes, it's that good also thanks to Lipor soil improvers. But is there any life beyond compost and biogas? That was the initial scope of the HOOP project, to go beyond compost and biogas. Yes, there are some technologies that are already available at high technology readiness level that allow you to produce, for example, biochar. Basically, you must consider lignocellulosic waste stream from plants, so garden waste or any kind of woody sticky material, either from biowaste or from the forestry industry. So with that kind of biowaste, you can get biochar, that it's a very well-known soil improvers, and depending on the biowaste and byproducts lignocellulosic stream that you use, you can market it as a fertilizer according to the recently amended regulation on fertilizer products, the European regulation. Who from our lighthouses has put the focus on this product, AWM again, and Savona University, representing the lighthouse of Kuopio in Finland. And then, of course, you can also produce kind of recovered mineral fertilizers like struvites and ammonium sulfate. You get them from digestate effluent and wastewater effluents. The two lighthouses that have focused their attention on these processes to get these specific byproducts are Lipor, again from Portugal, and Beer, from who is the waste management company from our lighthouse Bergen in Norway. And then there's the case of Ancilazio in Italy, representing the region of Lazio. They are betting on one technology from that allows to transform used cooking oil into P3HB biopolymers that have, this biopolymer have very interesting application in the cosmetic sector as active ingredient. It's not, I mean, it's not meant to produce the packaging, it's the active ingredient. Why is it interesting? Basically, because, sorry, I moved the slide. It's interesting also because in their region, they have stakeholders that either can provide the biowaste stream and also could potentially absorb the byproducts. At the moment, they are trying to find a promoter, and they have performed an excellent stakeholder engagement in the territory. These stakeholders came to visit the facilities of Navigate Corporation in Prague, so that they could really understand what was the technology and what is the market potential of the solution. And I don't really want you to read this slide. I just want you to understand that besides the technologies that I have presented you in the last slides that have high technology readiness level, there are plenty of other options that are at lower technology readiness level. And this is a graphical abstract of the HOOP state of the art. The abstract is public. The document's kind of Bible is confidential, and it's also very long. I think that there will be very few people interested in reading the whole document, but just for you to have an idea of what are the possibilities according to the waste stream that you consider and the final market sector that you are targeting. Besides all this knowledge, HOOP is also developing a lot of tools to evaluate the circularity of territories, to evaluate the circularity of projects, the maturity of projects intended as how appealing they are for investors, okay? And where you can find all these tools here in the HOOP Hub. If you navigate through the hub, you see that there are many sections. There is the evaluate section, so there is where you have to go. And if you want to enter the magic worlds of all the documents, videos, materials, etc., that we have gathered and created for you, you just go to the virtual academy. And if you are a city and region, of course, you can apply to the HOOP circularity label. This is, yes, a snapshot of the hub. As you can see, there are many sections. You can go to the Learn section to access the virtual academy. And that's all from my side. So thank you very much for your attention. If you want to enter now the HOOP Hub to start looking around, just you have the QR code, use the QR code and enjoy your navigation through the hub. Thank you very much.
Thank you, Elisa, for the very interesting presentation. There's a note from someone in Porto, I think, who's telling you that the purity of the biowaste has increased since the numbers you quoted. So that's good to know. There is the possibility to ask questions to Elisa, but I would ask you to please put them in the Q&A section. And waiting on that, I will give the floor straight over to Christoph for our second presentation, and then we're going to pick up the questions after his presentation. So, Christoph, the floor is yours.
Okay, let me shortly know if you can see my screen.
Yep, all good.
Okay, perfect. So hello everyone, my name is Christoph Baumann. I'm here coming from Münster. I'll try to shed some light on our experiences as a lighthouse in the HOOP project. And my topic today has the title From Waste to Resource, exploring the transformation of organic residues into biochar through pyrolysis. To give you a short introduction to the city of Münster, where I'm employed, we are the capital of Westphalia. We have a residential population about 330,000 inhabitants. And the city has sustainability very strongly in the focus. It's basically the bicycles capital of Germany, freshly renewed. We got the award in 2023. And we are also winner of the National Sustainability Award in 2019. We've got multiple awards as Federal Capital in Climate Protection. And we've also been recently accepted into the 100 climate neutral and smart cities by 2030 by the European Union. So we are very much focusing here in Münster onto sustainability. And I'm working at the Abfallwirtschaftsbetriebe Münster, the AWM, which is the municipal waste management company in Münster. We are ISO certified for quality, environment, and work safety, have around 450 employees who are working on tasks like the basic city cleaning, winter services, of course, waste collection and transport, but we are also performing recycling and the waste treatment. We have a very strong vision for the year 2030. We want to go from waste to resource, as my topic indicates, and make Münster a capital of waste prevention. Now, on this slide, you see a short overview of our very strong door-to-door collection. So basically our logistics here in Münster, for example, the biowaste is being collected weekly, so every week via door-to-door collection. And we've got a bi-weekly collection of residual waste, paper and cardboard waste, packaging and household recyclables, for example, and also additionally a monthly collection of garden and green waste in our garden and green waste bags, and a monthly collection of bulky household waste. So we try to offer a lot of services in the door-to-door collection, but we also try to supplement it with 11 decentralized recycling stations. As you can see here, they are at maximum in a distance of 3 kilometers for every citizen. So we try to make the barrier for the citizens to get rid of their waste as low as possible. And it's working quite good, as I would assume. On this slide, you can see our development of the organic waste recycling in Münster. I think we've been one of the first in Europe to implement the bio-waste bin, and we did this step by step throughout the city. We started in the early 90s with the implementation of the bio-waste bin. And as you can see here, the separation of bio-waste strongly increases with the ongoing rollout of the biowaste bin throughout the whole city. We also started with an anaerobic digestion in the late 90s. We started with a liquid fermentation and later on switched to a dry fermentation in 2015 because we had some technical difficulties, and this streamlined our processes very nicely. And we also started very early on with composting of our green waste, and later on also from our digestate. So what is very important for us, we are producing compost products from our bio-waste and also from the green waste. Due to the high impurities in our bio-waste, we wanted to achieve a sustainable behavior change within our citizens in Germany, in Münster, and we wanted to increase the quality as well as the quantity of bio-waste. so that we can produce higher quality compost products. And therefore, in 2017, we started a campaign called Aktion Biotonne Münster. It's the Aktion Biowaste Bin Münster, basically. And we wanted to get rid, or we wanted to improve upon our impurities in biowaste, which were at that time about 3.5%. And as you can see here, the first phase in 2017 was a very wide rollout of an education and information campaign, where we basically try to use every channel within the city to bring as much information about correct biowaste treatment to the Münster citizens as possible. We had these posters, we had a lot of flyers, we had these little stickers on every biowaste bin in Münster to make sure that the separation, that the Münster citizens always know which fractions or which materials are allowed and are not allowed. Our biggest problem is still plastics, but we are making very nice progress in this regard. And after the strong education and information campaign, we also used emails and all channels as good as possible. We tried to continue with a motivational campaign where we gave like tips and tricks to the Münster citizens how to make sorting easier. We tried to give them little helpers, these tools like the Biotonne, which is a design biowaste bin for the kitchen to make it easier for citizens to sort their kitchen waste within their kitchen, and it also looks nice and is easy to handle. And yeah, we basically try to motivate them as good as possible. And of course, all new information is fastly lost if you don't remind the citizens, and therefore we continued again with an informational campaign to remind the citizens that separation of biowaste is very important, and for example that plastics are a big problem still. We changed the colors of some of our biowaste collection vehicles to make them more apparent, to be more recognizable, and we really strongly got in contact with the citizens to make sure that they know what kind of materials are allowed and are not allowed in biowaste. And this all led to the final step, which is still ongoing. And these are the controls, or the manual controls of our biowaste bins. As you can see here, we have specific staff who are going around the city with very recognizable e-bikes and e-cars. And they basically check the insides of the biowaste bins the day before the collection. And if they see high levels of impurities within these biowaste bins, they add a yellow card to the biowaste bin, so that the citizen and the collection vehicle knows that this is not properly sorted. And the citizens have 1 week. As I mentioned, we have a collection schedule of 1 week. They have 1 week to get rid of these impurities, or they get a red card. And if they get a red card, they need to pay a fine, because biowaste is basically collected as a residual waste because it's too contaminated. And this is working very nicely until today. We've got very nice results. Our impurities decreased significantly. Also, the plastics decreased significantly. So we're seeing very nice results. So it's indefinitely ongoing due to these results. And now on this slide, you can see what we are basically doing with our biowaste. When we collect our kitchen waste in the biowaste bin, it gets again sorted, pre-treated to be made ready for the anaerobic digestion. In the anaerobic digestion, we are producing biogas, and this biogas is used in a cogeneration plant for energetic recycling. We are getting electricity and heat out of it. And the electricity is used in our own premises and our plants, but we are also connected to the Münster city grid for electricity, so we can also introduce it into the local grid. And the heat is also used as good as possible at the moment in our own premises, but we are not yet included into the local heat grid, so we cannot make economic value out of it. But we're looking forward to it. The side product of this anaerobic digestion is the digestate, which we are using in a digestate composting together with the monthly collected green and garden waste bags, which are shredded, and then we combine them, have a composting phase, and afterwards, after a fine processing step, which is important later, we get a quality seal certified compost, which we are selling to households and garden and landscaping customers, for example. Now, as Elisa already mentioned, the HOOP project offers a lot of nice tools For instance, the circularity label, which helps us to define our own or to evaluate our own circularity. We've had this tool with a lot of information and data about our processes, and we were able to identify a lot of potential for improvement in our processes. We already got a circularity level of 8, which is quite nice out of 10. But we identified areas, for example, our share of renewable energies. We are already producing a lot of electricity, but on the heat side, we can still improve. We can use more of our produced heat, and we can still produce more heat and maybe be also able to introduce it into the local grid in the future. And we only produce biogas and compost, so the number of bioproducts or innovative bioproducts is still limited, and we're trying to improve on this as well. So we got into discussions with the technical partners within the WHO project, and the technology we identified, which might be a good fit for our processes, is the pyrolysis, which is basically a negative emission technology. As you can see here, it has a it's very open to different kind of organic materials which can be used within this process, and you can produce a carbonizate, which is called biochar, as Elisa already mentioned. This is all done at about a carbonization at about 350 to 850 degrees, where you basically stabilize the carbon and concentrate the carbon, and you also produce a lot of heat. And this is all done under almost complete exclusion of oxygen. And in total, you get, as mentioned, a lot of heat if you perform this technology properly, if you have the right process parameters and a suitable input material, in best case, very woody. And the biochar has a lot of benefits if you use it in soil applications. And the most promising and the most important for us is the long-term carbon sequestration. So you basically form a very strong carbon sink, which is stable for several thousand years. So in total, we would get a new innovative bioproduct out of this technology with the biochar. We would get more renewable energy for our processes, and as benefit also, we would help a little bit in climate protection. So why are these carbon sinks especially important right now at the moment in the fight against climate change? Maybe, as all of you know, you've got basically 3 courses of action against the climate change at the moment, which is the avoidance of greenhouse gases and the reduction of greenhouse gases if the avoidance is not possible. And if both of these are not possible, you need to actively remove emissions from the atmosphere, which is called removal. In 2018, the International Panel for Climate Change, the IPCC, identified that negative emissions are strictly required to reach the 1.5 degree climate goal. So this is another point where we are very interested in these carbon sink technologies, and there are several ones. All of them are in the same way important. Some of these technologies are just a better fit for a specific purpose, for a specific context. And in our context, we are very much focusing on biochar because it has a lot of synergies with our processes. And as you can see here, it's basically the cheapest permanent carbon removal tool technology, as it's here right in the sweet spot between costs and the potential for carbon removal. So where do we see this technology to be implemented into our mentioned processes? So we are looking right now whether we can utilize our side product of the anaerobic digestion, the digestate, for pyrolysis. You can see it here. It looks kind of very high content of liquidity, but I will go into detail of this later. We basically just have very much of this material, and our digestate composting is basically always running at max throughput, so it would just ease our processes a little bit. And when we are fine processing these digestate compost into the quality seal certified compost, we get a lot of lignin-rich sieving overflow, very woody material, which we are using right now just for an external incineration. So it's not really used very sustainable, it's just used to produce energy, and not even by us. So we also want to have a look into these input material to see if we can make it usable for pyrolysis. We also have a lot of access to other potential input materials for this technology. For example, the green waste, which is brought to our decentralized recycling centers and is used just in a green waste composting. Here it's shredded composted and afterwards fine processed to also produce another kind of compost. And here as well, we are producing very wooden material as a sieving overflow. And this is also just being used for energetic recycling right now, at sometimes also for structure material in composting. But we want to go away from this energetic recycling and use it for material recycling. As you can see here, this is how the green waste look in Münster, and this is how the sieving overflow looks. As you can already imagine, we've got 4 potential input materials we are monitoring right now for feasibility, and we also see a lot of synergies with the products, the biochar and the syngas at our waste management company. For example, if you want to use biochar in soil applications, it's the best case if you activate this biochar. And activation of biochar basically means you load it with nutrients and you load it with microbacteria. And this is in the best case done with compost. And the synergy here is, of course, we are already producing 2 kinds of compost, so we can just combine them. And there's also another benefit. If you combine them, you basically already form a carbon sink. It is not usable for anything else than being a carbon sink. And therefore, the auditors, like for example, Carbon Future, can easily give you a registered carbon sink certificate, which you can already use in your own greenhouse gas balance, or you can sell it as another kind of income. We are also very eager to produce more regenerative heat. And as mentioned before, we are not yet able to introduce it into the local grid, but we are very much looking forward because we are being evaluated right now. There's a funding in Germany for the extension of the heating grids, and we are very close to a local heating grid in another part of the city of Münster. So this short distance seems to be not a big problem, and we are hopefully being included into the local heating grid to get economic value out of the new heat from such a pyrolysis plant. So there seems to be a lot of synergies here in our processes. So it makes a lot of sense to follow up on this technology in a waste management company, as this is at least my opinion. Here you can see our results from the feasibility studies. We checked the digestate input material together with the Ithaca Institute. As mentioned, it has a very high moisture content. And unfortunately, because we are mainly digesting kitchen waste, we have a low abundance of woody material and still sometimes up to 2% of plastic content. But on the other hand, we have a lot of it. So it's might be good to be usable. And we tested it. We had to dry it. It took a lot of drying effort. So if we would perform a monopyrolysis, so only of digestate, we might run into the problem that we won't get excess heat we could utilize. And the product had a rather low carbon content and on the other hand, a high ash content, which kind of decreases the quality of this biochar. And for some reasons, maybe due to abrasive events in the testing plant, we exceeded the quality limits for heavy metals, for nickel, chromium, and cadmium very strongly. And these are European biochar certificate limits, so the quality seal for biochar for the applications in agriculture and urban applications, for example, like city tree plantings, what we are targeting at the moment. So for these kind of biochar, we would only be able to use it in material applications, for example, in asphalt or concrete. And to make this more suitable, we could perform a co-pyrolysis. If we still only use it in material applications, so we don't use all the co-benefits of biochar in soil applications, we can also use our waste wood, A1 to A3, since this is also not allowed in soil applications. So combined, we could improve the amount of excess heat and a little bit the quality of the biochar. And this can then be used, for example, in climate positive asphalt, how they are doing it here on the other side of our border here in Germany, in Münster, in Enschede. They are using EcoFal to produce these kind of bike roads. And you can also produce CO2 neutral or positive concrete, for example. We also are looking into the possibility to use sieving overflows of the digestate composting, as mentioned. As you can see here, they have high fine contents, many impurities because it's coming from the kitchen waste, and we have unfortunately limited availability. But after a very fine pre-treatment with shredding and fine processing, we got a very woody fraction with a very high calorific value, so we get a lot of excess heat. And the biochar quality also looked very nice. We have a high carbon content, high specific surface area, a good water holding capacity, but also in this case, we exceeded 2 heavy metal limits for the quality, and this was nickel and chromium. But we are following up on that. The experts are pretty sure that nickel and chromium is coming from our processes, for example, from the shredder. So we just need to have a more effective fine processing to get rid of more fines and to check our internal processes to avoid these inputs. So just basically buy a different shredder and it should be fine. We at first also thought about green waste because we have just very much of it, but unfortunately it seems to be not suitable for pyrolysis, which I was very surprised about, because in this whole mountain of green waste, we basically only have 20% of woody material. And woody material is a material which you basically need for high quality biochar. On the other hand, you have very much a very high proportion of green cuttings, and these are basically not really suitable for biochar production. So you would need to get rid of it, which would result in high pre-treatment costs. And these very few woody parts are also very important for the composting of these green waste. So we would have kind of a biomass competition between the pyrolysis and the composting. So we are not looking anymore into this fraction. But when this compost is being sieved for the quality insurance, we get again a sieving overflow from green waste composting. This has hardly any contaminations, and it is also not very suitable for our structure material in composting, so we don't have this mentioned biomass competition. We also have just about 1,000 tons per year, so it might be a bit limited, but we are testing it right now and it looks quite nice. But the laboratories are at the moment very at their capacity, so we are waiting for weeks for the analysis results. Looking very much forward to it because it might be very suitable for pyrolysis. What do we want to do with our biochar if we're able to produce high value and high quality biochar? First and foremost, we want to use to see whether we can use it into the large local agricultural sector here around Münster and in urban applications. In the agricultural sector, you can use it either in cascading use, feed it to a cow. The cow will unfortunately defecate it into the area, and then you can use it again as a soil fertilizer, for example. This is a cascading use. You can just bring the single-use biochar, which is activated, for example, with compost, into the fields to increase the soil fertility and crop productivity. In urban applications, you can use it in city tree plantings or city tree regeneration projects, where it improves the urban green spaces and the stormwater management quite significantly, as it has been shown in Stockholm with the Stockholm system. And we are in discussions with Soilworks whether we want to produce high-value substrates, for example, to enhance plant growth and sustainability in private gardens, for example. Now, in the recent years, in the last 2 years, there was a recent amendment to the Biowaste ordinance in Germany. So some new obstacles to tackle for us with regard to the quality, because now in the upcoming year, we've got a defined quality which we need to reach. So within this ordinance, it's mentioned that the percentage of plastics in our biowaste must be less than 1%. And we have to check it on 2 occasions, once when it's delivered and once after pre-treatment before it goes into the biologic treatment. And this makes it very hard for us because if we have repeated violations of this new control value, the local authorities have to at some point deny us the acceptance of these biowaste. So it will just stop our processes, which is very problematic. So, and this is my last slide. We are already looking for alternatives. We want to enhance our biowaste inspections, the Aktion Biotonne I mentioned already, through automation. So we are looking, like you can see on the right side, on the implementation of automated detection systems, which shall supplement our manual inspections. And these are automated impurity detection systems, which will be deployed on our biowaste collection vehicles. They are using an AI-based recognition technology to identify impurities in biowaste. And this should help us to increase our coverage throughout the whole city of biowaste inspection, so we get a lot more information. And this shall help us to identify the hotspots of bad biowaste separation, so we can perform a very targeted educational campaign. Okay, I hope I was not too fast. Thank you very much. I'm very much hoping for interesting questions, and thank you for your listening.
Thank you so much, Christoph. That was super interesting. and thanks for sharing. We do have quite some questions. I would like to invite also Elisa to join us, so we can get your insight on some of these questions. So the first one is going back a bit in your presentation, Christoph, related to the awareness raising done in Münster. And the question relates to challenges within the first phase about educating and information. What the main challenges were, and I also maybe let Elisa, if she has any insights. I know you were active also in Murcia with the similar activities. So.
To be honest, I wasn't already employed at the AWM, so I was not involved in 2017. But I would guess, and this is an ongoing problem, is to choose the right channels to reach the citizens, which is always a problem. And yeah, we have a rather big budget for these kind of activities for a waste management company, which is, as far as my short experience in this area is, that it is not a normal that we have such a large budget, but for us it pays off in the end because we get a high quality biowaste, we have high quality biowaste products. At least we can look into production of biochar, for example, which gives us new angles to commercialize on these biowaste, which we get basically for free from the citizen. And this is a very nice angle if you, for example, compete with other biochar producers who have to pay for the input material. So I think this large budget helps a lot. In brackets, it's large. I think it's large for a waste management company. But yeah, this is all I can say to this at this point. Sorry.
That's fine. I don't know if Elisa, you had something to add on that topic.
Yes, I would say that the budget is the key. If I have to point out one of the main problems in Murcia in terms of efficiency of the campaign was the budget. The budget was very limited, so the communication campaign to the citizen was carried out only in one neighborhood. And now that the selective collection is going to be implemented in the whole municipality, they have not such a big budget, and so I'm quite confident about the fact that the quality will not be very good because you need to interact with the citizens. I would say that almost at the beginning every week for sure. And so if you have a big cities with 500,000 citizens, it makes evident that you need a lot of human resources that goes knocking door by door, delivering flyers, specifying the people what they can put in the biowaste bin, what they cannot. And that really depends on the waste management system. Because, for example, if your waste treatment plant is equipped with some, I don't know, tool XYZ, maybe you can accept one kind of improper material in biowaste. And maybe in the city that you were living before, the biowaste collection system was slightly different. Now you move to Murcia and you have a different collection. So it's very important to keep the effort. It's not like, okay, implement the biowaste selective collection system and I forget about it. No, you have to keep interacting with the citizenship a lot. And it means that if you don't have a big budget, you probably will fail in having good quality biowaste.
All right. Then we have quite some questions on your pyrolysis and biochar activities. So let's dive straight in. A question about, you didn't talk so much about pyrolysis oil, and the question whether you'd analyze those applications or no. Okay.
No, we are not doing this. We are not interested in the oil, but I can understand others if they are. For example, in one of our partners on the other side in the Netherlands, they are just basically only producing this oil and selling it to the companies. But we are very much more enticed by the biochar and its co-benefit. The first point, the carbon sink property, and also the co-benefits if you use it as a soil application. And this is what is interesting us more. And you can choose if you have the appropriate technology to produce these biochar, the pyrolysis oil, or if you directly burn it to get more excess heat. And we chose because we are potentially included to the local heating grid to get more excess heat and to utilize on this economic value. But it always depends on the context, I guess, if you choose to go for pyrolysis oil or not. If you have a lot of industry which requires this kind of resource, of course, go for the pyrolysis oil. It depends on your use case.
Elisa, is there any of the other cities that is looking into that? No. No, okay. Never mind. Very interesting. Okay, so further on the biochar, questions regarding what the biochar price needs to be in order to make a business case, and also related question, the value you get for the carbon certification.
The carbon certification value is increasing very strongly in the last years. I don't know. Is it now about 100? I don't have the exact price at the moment, and I think it will only increase even more now with the CRCF, the carbon removal certification framework, which is being put forward in Europe, where the biochar has also been at least mentioned yet. It's still being designed in Europe. How it will be implemented. So I think this price will even increase more in the future, but we are still planning to use them in our own greenhouse gas balances if we get to produce biochar here in Münster. And with regard to the price we need to achieve with this biochar, I cannot really comment on that because the biochar market is strongly changing right now. It is growing like crazy, and at some point, at least in the biochar meetings here in Germany and in Europe, it kind of appears at times that the market is growing stronger than the request for biochar. And in our case, it strongly depends what kind of quality our produced biochar will be able to reach. So what kind of EBC quality we get, if it can be used in agriculture and urban tree plannings, for example, we get a better price for it if we only get, in comparison, if we only get biochar which is used in material applications. These are usually cheaper. And it also depends whether we can utilize fully on the excess heat. If we can sell the excess heat to the local grid, of course, the biochar price can be cheaper for us to make it economically feasible. But these are all ongoing. We are still trying to figure out the best model, what kind of input material to utilize in order to get the most out of the heat and to get the most out of the quality out of the biochar. So it's a lot of moving parts on our side. But I guess for most of the technology providers, they always calculated if you are able to use the excess heat with a biochar price between minimum 350 euros to up to 500 euros. It's something like the actual price, which is calculated for basic quality biochar, something like that per ton.
Okay, very good. Then we have a question about the AI inspection for impurity reduction. How does that work?
So you basically, depending on your day-to-day business, you can choose two routes. So these kind of AI recognition technologies are mainly being developed here in Germany. We have a lot of technology providers here in Germany, which is kind of surprising. There's only like one another in France I know of. And you can either go the route that you check your biowaste bin before it gets thrown into the collection vehicle. So then you have still the opportunity to say, okay, we won't collect it because on the top view you already see too many impurities. So you can just leave the biowaste bin uncollected at the spot. So then you directly get rid of the impurities. But for us, for example, this is not feasible because it would put a too big constraint on our basic processes on our day-to-day business, because we would need to collect a lot more uncollected biowaste bins. You have got a second option with these technologies, is that the biowaste is collected. It is filmed within the collection vehicle. There you have got a lot larger area to make a definitely better analysis, and it's less prone to error. And then, of course, you don't have the benefit to get rid of the impurities anymore, but you get the information still where you've got these high impurity rates, in which area of the city, in which streets, maybe also in which house, if you got an identification system on your biowaste bins. And you can, as I mentioned, just focused on a very targeted information campaign and very targeted awareness actions. This is what we are targeting, because for our processes, it's not feasible to just let like 10% of all the collected biowaste bins, which are like 40,000 in Münster, just stand. It would be too big of a constraint on our workers. So we are targeting awareness raising.
Okay, I have one more technical question on the pyrolysis process. So it's going to have to be a quick one because we're running out of time. If you have problems with, here we go, PAH, polycyclic aromatic hydrocarbon in the biochar process, do impurities disturb the pyrolysis?
What I've learned, and I'm not a engineer, so please don't recite me on that, is that the production of these polyhydrocarbon aromatic, PH, whatever the abbreviation is, that it is completely dependent on the process of the pyrolysis. So basically, if you are running a optimized process, you won't get these kind of material, these kind of toxic products. And they also perform tests with like very prone with materials which are very prone or basically almost completely exist of these kind of toxic molecules. They also almost 100% got rid of these kind of molecules. So at least the optimized and top of the market pyrolysis technology plants are very, if they are used correctly, they should get rid of these kind of impurities or these kinds of toxic stuff. Sorry, very unengineered, this answer.
It's very good. Thank you very much. No, it's great. Well, we're pretty much out of time, so I'm actually going to close the webinar for today. So firstly, say thank you so much to Elisa and to Christoph for their super interesting contributions and for answering your questions. Sorry, there's a couple we didn't get to. Maybe I'll pass them on to our speakers, and they can write to you. But the good news for you is that today's session was just a teaser, really, because next month we are all getting together in Brussels and to have many more interesting presentations and discussions on all of these topics. So let me put the link in the chat. On the 4th and 5th of June is the HOOP Cities and Policy Conference. We're being hosted at the European Committee of the Regions. We want to get together all our municipal representatives from all of the HOOP cities with all of our HOOP network cities, all of our experts, all of our people interested in what's happening in circular bioeconomy in the cities to hear more of these kind of presentations, to discuss all of these topics together. We also have a session about policy to try to talk more also with EU policymakers about what needs to change on the regulation side. So I'm going to put the link in the chat now, and we'd love to see some of you there at that event. Also, just another plug, we also mentioned it at the beginning already for our Circular Bioeconomy Hub. And here you can gain access to different tools that we've alluded to during the presentations today. So on the next slide, you see the QR code. I've also already put a couple of times in the chat the link to the HOOP Hub. So please do go there, and hopefully there's something of interest for you. And finally, to say, I hope we'll see you back for one of the upcoming webinars. We have 3 more coming up the rest of this month. Make sure you register, come and join us. There's lots more interesting presentations to come. So a final thank you again to our speakers. Thanks to all of you for joining us, and hopefully we'll see you again in a couple of weeks. Have a nice day. Bye-bye.
Bye-bye. Thanks for having us.